Welcome back. You knew it couldn't be that easy. So in this video, what we're going to do is we're going to expand on our concepts of being able to evaluate different integrals. And we're going to, what it's called is change of variables of indefinite integrals. And basically what ends up happening is if you look at this integrand right here, that is chain rule. So we're taking the opposite of chain rule, we're going the other way around. And we're going to be using some U substitution. This is where the letter U comes in. And unlike chain rule, where chain rule you got good enough at it, you didn't have to write down U every time. In this one, when you integrate, I would suggest that you write down U every time. The more you try to do in your head, problems become more complex. You don't want to do that. You'll get yourself confused. So let's look at some examples of this. It makes more sense when looking at these examples. So in this one, I have composition of a function. I have a square root of 5x plus 7. The inside function is what I want to be U. So I'm going to let U be 5x plus 7. And then you want to take the derivative, du, which is 5 dx. And then I want to rewrite my integral using U substitution. I'm going to replace this 5x plus 7 with U. I'm going to write that as U to the 1/2. I'm going to replace dx with 1/5 of du. And since that's a constant, I can always pull constants out in front of my integral. You can just write this with a 1/5 out front here because that's a constant. And then I write it as u to the 1/2 power du. So when I integrate, I can't have x's mixed with du's, and I can't have u's mixed with dx's. So you got to replace dx with 1/5 of du. You have to replace 5x plus 7 with u. Now we're here. This is what we learned in the last video. We're just at power rule. So it's 1/5 times u to the 3/2 divided by 3/2, which is going to be multiplied by 2/3 in a second, plus c. Keeping on going, if I multiply by 2/3, it's going to be 2 over 15 times u to the 3/2 plus c. And then I'd like you to put u back in. I'd like you to write the answer as 2 over 15 times 5x plus 7 to the 3/2 power plus c. Anytime you have composition of a function, you have to use this U substitution, change of variable, rewrite the integral. So like in this one, my outermost function is cosine, my inner function is the 4x. So this time U is going to be 4x. du is going to be 4 dx. So I'm going to multiply it both sides, or multiply in front of the integral by 1/4. So it's going to be 1/4 times the integral of the cosine of u du. Again, got to change it all to u. Can't have an x and a du or a u and a dx. Take the antiderivative. We're back at our last video, so it's going to be 1/4 times the sine of u plus c. And then I will put the 4x back in there. So 1/4 sine of 4x plus c. In a lot of cases, you're going to have this straight substitution where you can replace that 4x pretty easily. The derivative is just 4 dx multiplied by 1/4. Most of the time, you're going to be able to do that. But sometimes we hide the substitution, things like this. In this problem with that x squared minus 1 dx on top, and then the x cubed minus 3x plus 1 on the bottom raised to the 6th power, I'm going to let, you have choices. In this case, I'm going to let this part that's being raised to the 6th power, that part in there, that's going to be u. So if u is x cubed minus 3x plus 1, then du is going to be 3x squared minus 3 dx. And that's not exactly our numerator, but it's related to it. Because if I factor out a 3, I can rewrite this as 3 times x squared minus 1 dx. So now if I solve for x squared minus 1 dx, that is 1/3 of du. So 1/3 of du is x squared minus 1 dx, which is our numerator. So now what I can do is I can rewrite the integral as 1/3 out front times the integral. This part is u, and it's to the 6th power. So I'm going to write it as u to the negative 6th power because that's the format that I needed to take the antiderivative. Now I'm at power rule. Add 1 to the power, divide by the new power. So it's 1/3 times u to the negative 5th divided by negative 5 plus c. And then I'm just going to go ahead and I'm going to do a couple of things. I'm going to multiply that negative 5 times the 1/3. And I'm going to put the u to the negative 5th back down in the denominator. And I'm going to plug in the x cubed minus 3x plus 1. So it's going to be 1 over negative 15, and it's going to be x cubed minus 3x plus 1 to the 5th power, and then plus c. All right, I'll do some more examples of this. Obviously, this u substitution is going to be a big deal. It's going to be in a lot of the problems you're going to do throughout this unit and beyond even. So you really have to master this. You have to understand what you're doing. Just be careful. Be careful with the little bit of algebra stuff. Be careful about multiplying things. Make sure you add one to the power. Don't subtract by the new power. That kind of stuff like that. That tends to get people in trouble. Good luck. See you in class.